Today in class we saw that there are two major groups of compounds, the ionic compounds and molecular compounds. And the way we test for them is that ionic compounds like sodium chloride will conduct electricity when they're dissolved in water because that releases ions into the solution. The molecular compounds do not, so we're going to use ethanol as the example of that. There's a third type of compound that does something really interesting that we're going to demonstrate here. So I'm going to turn the lights off so you can see it better. So we're going to use our conductivity meter to test these conductivity of these solutions. The sodium chloride conducts very nicely because there's free ions that are dissociated in the water. I'm going to rinse this guy off. Ethanol, no conductivity because there are no free ions generated when molecular compounds dissolve. Citric acid, this is the compound that makes your Skittles sour and most other candies, as well as, of course, citrus fruits. If we test the conductivity of this compound, we get the barest, just the dimmest little glow, right? So that's much dimmer than what we saw in the sodium chloride. That's a nice bright glow. When we switch this to the citric acid, we get this dim glow. And so what this means is that citric acid is a molecular compound. Somehow it's producing ions. This is going to lead us to the one exception to the molecular compounds not dissociating that we're going to find when we get to acids in a couple of weeks. Right now, we're going to kind of stick with the either or, the conductive ionic molecular compounds, the non-conductive molecular compounds, but we want to keep in mind in the back of our heads that later on we're going to come to the exception, which is going to be the acids.